Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 17 in our incredible tutorial series where you're teaching the robots who's boss. I'm going to need you to pour yourself a nice cup of hot black coffee. That would be strong black coffee, no sugar, no sweeteners, none needed. And I'm going to need you to get out your robotics gear. And as always, as you are getting your gear out, I want to give a shout out to you guys that are helping me out over at Patreon. It is your encouragement and your support that keeps this great content coming. You guys that are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to learn today. We are going to be looking at the solution to the homework assignment that I gave you in lesson number 16. Now in lesson number 16, we got this most excellent HC-SR04 ultrasonic sensor working where we could launch a ping, the ping would go out and bounce off of a target and come back, and we could measure how long it took for the ping to get to the target and back. And then we also saw that that was kind of proportional to distance. If we doubled the distance, the ping travel time doubled. And so we got the sensor up and running. We seem to be taking good measurements. But what your homework assignment was for today was to turn that ping travel time into a calibrated distance. Now what I certainly hope is, I certainly hope you didn't do that by getting a ruler and making a measurement and then just kind of doing if statements for different measurements. I hope you did it the way that an engineer would. I hope you did it, yes, using math. But what I'm going to do today is I'm going to kind of show you how I think about this. And so let me see if I can get a nice view here and get my system where you can see things. This will take me just a second to get things all lined up here. And I think that if I go to this view, that should be a good view, and hopefully you can see things here. So let's see. What we ended up in lesson 16 is we could measure the ping travel time, the time that it took for the ping to leave the sensor, go to the target, bounce off, and come back. So we had a ping travel time. And then some of you guys, I told you to stop the video if you didn't want the hints. You guys let me know down below whether you were able to do it. Like maybe I folded up like a cheap lawn chair. I was able to do it with your hints, or I was able to do it completely by myself without your hints. But what you got to see is you've got to look at this as you're measuring time, but you want distance, and so you need to know a little formula, which hopefully most of you guys would know. Let me get this here. Hopefully most of you guys would know that distance is equal to rate times time. And this sort of makes sense. If you're going 60 miles an hour, that's a rate, and you go for 2 hours, you're going to go 120 miles. Distance is equal to rate times time. Now the thing is that we're going to get distance, and then the rate, let me see here. I should have looked this up already, but the rate would be what? The rate would be the speed of sound. So let's come over here real quickly and let's look up the speed of sound. Okay, and the speed of sound, I don't want it in meters per second, 761 miles per hour. Okay, so the rate is 761 miles per hour. Okay, 761 miles per hour. Okay, so that's the rate, and now the time is what? The time is our ping travel time, right? So we measure that, and when we measure that, it is in what? It is in microseconds. All right. Now, this is why dimensional analysis is so important. That if you just look at this, what you can see the problem is that I'm in miles, my unit is miles, and what did I want? I wanted distance in inches. Okay, I wanted distance in inches, and this is in miles. And so one thing I'm going to have to do is I'm going to have to convert 761 miles. I'm going to have to convert that to inches. And the second problem is I have time over time. I have time over time, but those don't balance because in the numerator I have time in microseconds and in the denominator I have time in hours, and so those won't multiply together to give you a they're not going to multiply together to give you a distance. And so I've got to get all my units working. Okay, I've got to get all of my units working. So let me see if I can get rid of those markings so we can give ourselves a little more space here. Okay, so let's try to jump in here and let's see if we can do this. So now I want distance, and I want that in what? I want that in inches. Okay, I think you can read that. And now what am I in? I am in 761 miles per hour. And then I'm just going to put PT for ping travel time so that it makes the abbreviation a little bit easier. And that is in microseconds. Okay, so I don't want microseconds in the numerator because that will not cancel hours. So what do I want in the numerator? I want hours in the numerator. Because I have hours in the denominator, then those two things will cancel to leave me in a distance. And so how would I do that? Well, I know that 1 second is 1 million microseconds. Okay, 1 second is 1 million microseconds. So really I'm just multiplying by 1 because 1 second is the same as 1 microseconds. Now microseconds and microseconds are going to cancel. Now what units am I in? I'm in seconds, but then the problem is that that's not going to cancel hours. So I need to go from seconds to hours. And so I know that 1 hour is 3,600 seconds. 1 hour is 3,600 seconds because 60 seconds in a minute, 60 minutes in an hour. And so now hours and hours are going to cancel. Seconds and seconds are going to cancel. Microseconds and microseconds are going to cancel. What unit am I going to be in now? I am going to be in miles. So the good news is now I am in a distance, but now I'm in a distance because all the times have canceled out. What do I need to do now? I need to convert miles to inches. And so how would I do that? Let me get out of your way a little bit more to make sure that you'll be able to see me. Okay, so now what we're going to do is we're going to come in, and I want miles in the denominator now to get rid of it. I know that 1 mile is what? I wrote this down. It is 5,280 feet. 5,280 feet. Okay, so now mile and miles, miles in the numerator, miles in the denominator will cancel, and I will be in units of feet. But I don't want to be in feet. I want to be in what? Inches. Okay, and so I'm going to say 12 inches is equal to 1 foot. Now watch this. All the units are going to cancel. Feet in the denominator cancels feet in the numerator. Miles in the denominator cancel miles in the numerator. Okay. Hour in the numerator cancels hour in the denominator. Microseconds in the numerator cancels microseconds in the denominator. Okay, seconds in the denominator cancel seconds in the numerator. And so what am I left with? I am left with the units of inches. So this is what you do. Distance, and I'll go to a different color here. Now we're going to combine all of these different numbers into one calculation. Distance in inches is going to be equal to 761. So I've got to go across and put all the numerators in, times 5280. So I get that. And then times 12. I get that. Now I've got to divide by all of the denominators. And so that is going to be 1 million. I'm going to divide by 1 million. Okay, and then I'm going to divide by 3,600. So I've got the 1 million, and now I've got the 3,600 in the denominator. Okay, and then I still need to put in my ping travel time, and I'll go back and make it our full variable. I need to multiply it by ping travel time. Okay, now where do I get ping travel time? I measure it. That's what we did last time. I measure the ping travel time. I take that number, which is in microseconds, I multiply it by 12, multiply it by 5280, multiply it by 761, divide it by a million, divide by 3,600, and that, my friend, will give me distance in inches. Now, if you don't understand what I just did, you need to go search on my channel. My channel has a video on dimensional analysis. You need to go watch that and understand it. I don't want you to just copy and paste or just follow along with what I'm doing. I want you to understand this calculation, because I will tell you that as an engineer, dimensional analysis is one of the most important skills that you need. Every single problem that you're going to solve as an engineer is going to require you to understand dimensional analysis. And it's very easy. What you're doing is you're just going through and multiplying by 1, multiplying by 1, multiplying by 1, until you get the units that you want. What do I mean by multiplying by 1? Well, 1 second is 1 million microseconds. I multiplied by 1. 1 hour is 3,600 seconds. I multiplied by 1. 5,280 feet is 1 mile. I multiplied by 1. But you just got to do it so that the units that you don't want are canceling out and you're left with the units that you do want. I hope this makes sense. Okay, let's jump in and start coding here. I think that what we will do is we will come in and we will go over to this view and we will open up a fresh new Arduino IDE. We will quench our thirst with a little hot coffee. And now what we want to do is we want to go ahead and start where we left off in lesson number 16, because we were already measuring ping travel time. So we can go to the most excellent www.toptechboy.com. I need you to use the happy little search icon and search on robotic training lesson 16. And then you can come down here and you can grab this code which we developed in the last lesson that allows you to measure ping travel time. And so I'm going to paste this in. And so this is just very simple. It sets up the sensor pins, and then I set up a, or I should say we set up a function to measure ping time. And that comes up and it puts it in ping t. All right. Now, what I want to do, though, is I want to create a new function, and I will do that down here at the bottom. And that is going to be int. It's going to be measure distance. Okay. It's going to be measure distance. And what am I going to want measure distance to do? Well, the first thing that it is going to do is it is going to measure ping travel time. So I'm going to create an int here, and I'm going to call it ping travel time. Now you might be asking, why are you having to redeclare the variable? Because this variable up here, ping travel time, is only recognized within the scope of where it was defined, and so it was defined inside of this function, and so this function won't know anything about it. And so I'm redeclaring it here. Okay, and then I'm going to say ping travel time. I'm going to measure ping travel time, and I'm going to do that by calling what? Ping time. So if I call, that's med dist, no, it should be measure distance. If I call measure distance, what measure distance is going to do is it is going to measure the ping travel time. By calling ping time, it comes up here to ping time. It measures ping travel time. It's going to return it. Return it where? Return it back to this function which called it, and it's going to put it in ping travel time. So at this point, I now have ping travel time. Well, what do I want to do now? I think what I want to do now is I want to put this equation in there. So I need to take ping travel time, I need to multiply by 761, multiply by 55280, multiply by 12, divide by 1,000,000, and divide by 3,600. Now if I put that equation in, I should have distance. And so let's see if that will work. Had to write it down because I can't look at them at the same time. Also, I'm going to need to have another variable that I'm just going to call distance. Okay, like that. And now I need to calculate distance. Well, what is distance going to be? Well, we just did all of that dimensional analysis. It is going to be, and I'll use parentheses for the numerator, and then I'm going to use parentheses for the denominator, so I keep track of what's in the numerator and denominator. But I'm going to have ping travel time, and then to do the unit adjustment, I need to multiply by 761, that was the miles per hour of the speed of sound, multiplied by 5280, which was the number of feet in a mile, and multiplied by 12, which was the number of inches in a foot. So now I should be in inches, and now I need to divide by 1,000,000, and then I need to also in the denominator have 3,600 because that was the number of seconds in an hour. So 60 seconds in a minute, 60 minutes in an hour. So if I did my dimensional analysis right now, this distance, that distance should be the actual distance. So what do I want to do with measure distance? I want to return what? Return distance. Okay, return distance. Now I come up here to my main program, and I don't need to call ping travel time. Why do I not need to call ping travel time? Because this function, measure distance, will call ping travel time. So all I am going to do is I am going to now declare another variable, and I will call this int, and I'll call it target distance. Okay, and that's what I am going to measure now. I'm going to come down here, and I am going to take this out, and I am going to say target distance is equal to what? Well, I am going to measure distance. All right, so now let's make sure I did my variables right. Target distance, that looks good. And so what is this going to do? I'm going to call the function measure distance. I come down here to measure distance. It will measure ping travel time. It will calculate distance. It will return distance. And then distance will come up here, and it will go into the variable target distance. And so now I want to print what? I want to print target distance. Okay, now what is the chance that this is going to work? And let's see if I can kind of set this up a little better where you can kind of see what this is going to be doing. I sort of need to do some adjustments here. Give me just a second for a little audio visual setup here. Okay, and let's just look and see. Let's just see if this thing will run to begin with. Okay, let's just see if this is going to run. My camera is really kind of a mess right here, so I want to see if I can get it. So you can see that it's just going to come, the ping is going to come off of here, and it's going to go to here, and it's going to come back. Okay, so now let's see if we can run this. And so I will hit the download. Oh, denied. What did I do wrong here? Oh, I did not put my semicolon in. Man, I was really hoping I wouldn't have an error here. Okay, and we forgot to hold our breath. So this time, let's hold our breath. Ooh, what did I not do there? Did I not put a semicolon? Oh, man, I've been doing too much Python programming, and I'm not putting my semicolons in. All right, one more time. Everyone hold their breath. Someone didn't hold their breath that time. Everyone hold their breath. Yes! Yes, we have the happy little bar. We have the happy little blue bar there. And so we did it. Now, just because it downloaded doesn't mean that it is right. And so let's kind of just look at what our target is to see if we can get a rough idea. And I just had a ruler here, a tape measure. And so let's look and see. It looks like the target is roughly about 8.5, 9 inches. And so now let's open up the serial monitor and let's see what we are getting. We are getting all zeros. I know why we are getting zeros. I think we defined this as a int, distance as an int, and 761 divided by all of this, it's going to round to 0 probably. And so let's come back and let's make our ints floats like that, and let's see if that'll make a difference. A lot of times if you're doing math and you get a 0 where you're not expecting it, it's because you're getting round off of your integer number to 0, and I think you guys have probably seen that before. And so let's see. Okay, I really hope it works this time. Okay, boom, look at that. All right, now what's the good news is I'm getting a measurement. All right, what is the bad news? The bad news is that I am about 8.5 inches. You see that I'm about 8.5 inches and I'm measuring 17. What could possibly be wrong? All right, so there is a conceptual error in what we just did. Now, what I want you to see, though, is now let's kind of set it at 4 inches. Okay, if I set a target at 4 inches, it's now measuring 8 inches. So what do you notice? Is it a random error? No, it's not a random error. It seems to be a systematic error. And so what I want you guys to do is I want you to pause and I want you to put down in the comments what conceptual or what analytic error I made. It seemed like I did everything right, but there was something that I wasn't quite thinking of correctly that led to this. Okay, I'm going to give you a second. Leave a comment down below. Let me know if you caught it as I was doing it, or if you just sort of, after you saw that the number is off, that you figured out what it was. Okay, let me explain what it is. All right, I want you to think, what does the ping do? The ping comes from here, it hits the target, and it comes back. So what you have to see is the target distance, the distance of the target is not the distance that the ping traveled. What did we calculate? We calculated the distance that the ping traveled. The ping goes from the sensor to the target and back. Therefore, target distance is going to be what? Class? It's going to be what? It is going to be this distance, which is the ping travel distance, it is going to be that distance divided by 2. And so we can just make that adjustment here. Distance is equal to distance divided by 2. Now, why is that? Because I don't want the distance that the ping travels. I want the distance to the target. So let's try this. Okay, I'm not even going to hold my breath. I am so confident this time. I am not going to hold my breath. All right, it looks like it downloaded. And now we are going to open this up. Okay, look at that. Boom! Look at that. It's measuring 8 inches. Okay, and now let's see if I put something at the halfway point. Now it is measuring 4 inches. All right, that is very, very, very good. All right. One thing I see here that I don't like very much, though, is on distance, I defined it as an int. And really, I want fractions of an inch, so I'm going to call it a float, okay? And that way, instead of just being 3 inch, 4 inch, 5 inches, it might be 3.67 or 2.54. It'll give me the fraction of an inch. So I'm going to define distance, and then since I'm returning distance, I need to also, where I defined it up here, right, that I've got in my main program, I am calling it target distance. I need to also make that a float. Okay, and right, the floating point numbers are like the real numbers. They're the in-between numbers. And so let's download this and see what happens. All right, so let's open this up. And let me get a target here. Okay, 8.00. That's kind of neat. I hope... Ooh, all right. It's kind of interesting that it is giving me only exactly integers still. So I got to figure out, I'm still getting exact integers here. So let's figure out exactly why I am not getting something that looks like floats. Okay, so target distance is a float. That's good. Target distance is equal to measured distance. Ah, guys, what did I call this? I said that it is going to return an int. So I need to make the function itself a float as well. I hope you guys caught that. That was kind of a... That one scared me because I was thinking I made everything a float. Why is it an int? Well, and then ping travel time, it should be an int because it's just the pulse in number that's being returned is always going to be an int. So this should work. Let's see. I hope it doesn't come out up to 8.0 here. All right. So it downloaded. Let's open it. 8.61. Shazam. Do you see that? Look at that. So now let's put this here. Okay. And 3.2, 3.4 coming out for... Look at that. Now, I do think probably reporting to 1/100th of an inch is not really accurate. I think you would be doing well to get 1/10 of an inch. And so you probably want to not try to use that second decimal point. It would be kind of like you're probably good to about 1/10 of an inch using this. But I'll tell you, that is very exciting to me. Guys, I am so excited to be back here making lessons again. I hope you guys are having as much fun taking these lessons as I am in making the lessons. Okay, now I need to give you a homework for next week. And what the homework for next week is to take your Elegoo Smart Car. And what was it? Was it lesson 15? Lesson 15 was the lesson where we had our cell phone and our smartphone, and we were controlling the smart car using the Bluetooth. Well, what I want you to do is I want you to go back to that lesson that we had in lesson number 15, but I want you to just have it where as your car is driving, it looks for obstacles, and if there is an obstacle, I want you to just stop the car. You don't have to avoid the obstacle, but just stop the car so that it doesn't run into the obstacle. And so this would be actual kind of like obstacle detection, and the program's not going to be that smart. It's just going to see I've got something in my way, and therefore I have to stop the car so I don't run into it. Okay, so that's the homework. Now you're going to have to think a little bit, because remember on that lesson 15, I think we said like go 10 feet, and we went 10 feet by turning the motors on and just letting them run for a certain amount of time. And during that time the motors are running, I think you probably have like a delay in the program. Well, you can't be making measurements during that delay, so you're going to have to kind of make the program a little bit more sophisticated, where you go a little bit, look for an obstacle, go a little bit, look for an obstacle, and then end up going the full distance that you had programmed in. Okay guys, I hope that you're enjoying these. I'm really having a lot of fun making these lessons. If you like this lesson, give us a thumbs up. Think about sharing this on your social media. If you like the channel, subscribe to it. Make sure you ring that bell when you subscribe so you'll get notification for future lessons. And again, guys, really appreciate you guys that are helping me out over at Patreon. It's a huge encouragement to me, and it motivates me to keep this great content coming. Okay, guys, this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.